The topic of this project is Let's watch a math game become easier by reordering curriculum sequence. This is the final presentation for NCWIT Collegiate Award. One motivation for this project is an article by Harrington in 2016, which shows that many adults have been traumatized by mathematics, and one way to alleviate this is by introducing math games and puzzles to children as early as kindergarten. However, a math game with a curriculum sequence that does not teach math skills in a hierarchical manner is counterproductive. This research infers an optimal curricular sequence which promotes effective learning experiences by suggesting prerequisite objectives to students earlier in the sequence. In this project, we improve learning on a math game called Spatial Temporal Maths using machine learning techniques. Estimat is a curriculum-integrated math game that acts as a year-long supplemental program to the existing math curriculum in elementary classrooms. The game is designed to enhance students' K-12 math skills through spatial visual representation and informative feedback. Estimat content is divided by grade level and aligned to relevant Common Core. Estimat is currently being used by over 1.2 million students and 56,000 teachers in 48 states across the country. Estimat objectives are broader mathematical concepts. Puzzles are contained in levels, levels are contained in games, and games that teach related maths concepts are contained in objectives. In this study, we analyzed gameplay data by third graders in 5 U.S. districts during the 2017-2018 school year. Let us first define some important concepts. Retries are level attempts other than the first attempt that occur before the student passes the level. Retries are different from replays in Estimat. Replays on the level are all attempts that occur after the student passes the level. So many retries indicate a lack of understanding. Therefore, reduction in retries indicates a reduction in the difficulty of objectives. We conducted a preliminary analysis to discover the sequence of Estimat objectives played by elementary school students in 5 U.S. districts. This figure is a sample from our dataset. It shows a bar chart of the sequence with which 5 districts, namely Districts A, B, C, D, and E, played 5 Estimat objectives. The number in each bar represents the position of each of the 5 objectives in the curriculum of each district. Please note that District B did not play place value bundles, tens, and hundreds, and District A did not play concepts of area and perimeter. From analyzing sample data, we can see an important pattern that the rise and fall in the number of retries needed before passing some objectives co-occurs with the position of such objectives in the curriculum sequence. Using this pattern, we categorize the objectives into 3 major groups. Group 1 objectives are difficult, that is, they have high number of retries, or easy, that is, they have low number of retries, depending on their position in the curriculum sequence. Group 2 objectives have a low number of retries no matter their position in the sequence, while Group 3 objectives have a high number of retries no matter their position in the sequence. From the plot, we can see that 2 objectives, namely place value bundles, tens, and hundreds, and number patterns, fall into the first group because their percentage retries dropped when played later in the sequence. Let's closely examine the first objective. Place value bundles, tens, and hundred. When played earlier as the second objective by students in District A, it recorded about 9% retries. This means it was more difficult. Whereas when that objective was played as the 14th objective in the sequence by District D, it recorded about 3% retries. This means it was easier, and students in District D must have obtained prerequisite skills from the 1st to 13th objectives before working on this 14th objective. From the plot above, Multiplication concepts and division concepts fall into Group 2 because they are easy no matter the order they were played. These objectives are already well placed, so their current order should be maintained. Some of these objectives could be played at the beginning of the sequence to help students become more familiar with the game environment. Concepts of area and perimeter falls into Group 3. From our analysis, we discovered some game mechanic reasons for this, such as the potential lack of intuitiveness of the game. We suggest that the game should be redesigned. Note that we've made suggestions for playing objectives in Group 2 and 3. We are left with Group 1 objectives. We decided to investigate what makes an efficient curriculum sequence for this set of objectives. We replicated the 2017 study by Liu et al., which introduced the novel method for determining pairwise orderings for objectives in the curriculum using mixed effect regression. We used the inference from our replication study to suggest a partial order for objectives in Group 1 based on the predictive abilities of objectives. The sequence of earlier objective to later objectives goes from left to right. Districts that already followed our suggested order recorded a reduced number of retries for Group 1 objectives. Our research was published in a paper titled Data-Informed Curriculum Sequences for a Curriculum Integrated Game as part of LAC 2020 conference proceedings. In conclusion, students gain self-confidence as they perform better and are now equipped with the knowledge from prior objectives which are required to ace later objectives. This kind of student modeling is beneficial to both the serious game and analytics communities. Thank you.